In this lecture, we will be discussing one more example to find the maximum or minimum values, if any, of a given function. The function given here is f of x is equal to sin x plus cos x. So note that this function is sum of two trigonometric functions, that is sin x and cos x. It will be convenient for us if we express this function in terms of a single function, that is either sine or cos. Now to do this, we will multiply and divide by root 2 this expression sin x plus cos x. This implies f of x is equal to root 2 times 1 upon root 2 sin x plus 1 upon root 2 cos x. So see that if you simplify, you will get back this expression sin x plus cos x. We know that 1 upon root 2 is sin pi by 4 and cos pi by 4 as well. Therefore, we will replace this 1 upon root 2 by cos pi by 4 and this 1 upon root 2 by sin pi by 4. So, we will get f of x is equal to root 2 times sin x cos pi by 4, because as I said 1 by root 2 is this cos pi by 4 and this 1 upon root 2 is sin pi by 4 and this cos x is here. This is sin x cos pi by 4 plus cos x sin pi by 4. So this should remind you of a trigonometric formula, sin A cos B plus cos A sin B is equal to sin of A plus B. So if we apply this formula over here, instead of A here we have x and for B we have pi by 4. Therefore, this becomes root 2 times sin x plus pi by 4. The function fx now is redefined as root 2 times sin x plus pi by 4. Now, we know that sin y lies between negative 1 and positive 1 for all y belonging to the set of real numbers. Therefore, I want to replace this sin y by this sin x plus pi by 4 here for all x belonging to the set of real numbers. Now that in this function fx, root 2 is multiplied with this expression. Therefore, let us multiply this inequality throughout by root 2. So, this will give us negative root 2 less than or equal to root 2 times sin x plus pi by 4 less than or equal to root 2 for all x belonging to R. But this root 2 times sin x plus pi by 4 is nothing but fx. So replacing this expression by fx, we will have negative root 2 less than or equal to f of x less than or equal to root 2 for all x belonging to R. So clearly fx lies between negative root 2 and positive root 2. What does this indicate? This shows that fx has a maximum value of root 2 and it has a minimum value of negative root 2. The same thing we will understand by means of a graph as well. Here is the graph for the function fx is equal to sin x plus cos x. If we observe the graph, the maximum value that this function is taking is this red line we can see here. This is nothing but root 2. Note that root 2 is 1.414. So, if you see in the graph, this is 1, 2, 3, 4. So, 1.4 and a tiny part is left here which can be 0.014. Therefore, this is 1.414. Hence, the maximum value of f is here root 2. Similarly, the minimum value here is negative root 2. Hence, we conclude that the function attains both the maximum and minimum values.